Alrighty, good afternoon or good morning, ladies and gentlemen, whenever you get around to it. I'm going to go over a couple of points for our math review sheet. This should also update in your notes, so if you want to take a look at what I've done afterwards, feel free to check out our class notebook. But again, remember this is optional, but take a good look at it, go through it. If there's anything that you're like totally just not feeling comfortable with, that's where you should spend the most time, and if you're still not getting it, feel free to ask me. That's what I'm here for. We're going to start simple with bed mass. This is which order we do things in. So ideally, or what we want to do is we want to start from the top and work our way down. So we start here and go down. So brackets, anything that's in brackets we do first. Exponents come next. Roots, division, multiplication, addition, subtraction. You may have heard this as like ped mass, or where the B is a P, or bed mass. Same thing. We're now just including everything and giving it this sort of term. One thing that I want to add, whenever we have this opposite operation, so one of the things it points out is that exponents and roots are together, division and multiplication together, and addition and subtraction together. We can say that they happen at the same time, but generally speaking, we don't do it all at the same time, so oftentimes another convention is left to right. So if you have something like 4 times 5 divided by 2 times 7, they're all kind of happening at the same time. I know this says do division first, but then you would get 5 halves or 2.5, and it makes things complicated for when you're multiplying this. So if I run through this, 2.5 times 4, it gives me 10, and then times another 4 gives me 40. So let me show you, doing it in a different order doesn't matter. 4 times 5 gives me 20, divided by 2 gives me 10. Oh, did I make a mistake? Oh, this should be a 7. So this is 70. And so this area here would give me 10 times 7 gives me 70. So it doesn't matter which order you do it in. So with that in mind, if you end up with something like this, don't feel like you have to do it and give yourself some sort of ugly fraction that you then have to multiply. Because everything happens at the same time, it really doesn't matter which order you do it in, but it only applies to these sort of opposite operations. So pick and choose what makes it easy for you, but you can't combine a root with addition. Those have to happen at separate times, but really we can break it down into do brackets first, then do exponents and roots, then do division and multiplication, and then finally do addition and subtraction. Alright, keywords, I'll skip. For exponents, a quick review. There's several components to an exponent I have here. So x, the number on the bottom, is the base. The little number on top, which I've represented with an n, is either the power or the exponent. So you'll hear it called either one of those things. And this basically reads multiply x by itself 10n times. So for example, if you had 2 to the 4, this would be 2 times 2 times 2 times 2. So there's going to be 4 2's, and you're multiplying them all together. So whatever that comes out to be is going to be your value. Moving on, I want to keep this a nice, short and sweet video for you. Fractions to decimals. So if you want to change a decimal into a fraction, look at how many numbers you have. That is going to be the number, or the number of digits in your value. So say if you have like 417 and you want it, and it's over 10, you have 3 digits here the decimal place is invisible and goes here. The 10 that's underneath it, there is 1 0. And for every 0, when you divide, you're going to move the decimal place over that many times. So in this case, 1 0, decimal place, moves left 1 place, which means I change this to 41.7. So all I've done is I've taken this and I've shifted it over. For some of you, this is going to be review, it's going to be easy. But if you notice in each of these, we start with 3 over 10. There is a decimal place here. They've moved it over 1, so it's 0.3 or 0.3. There is now 2 zeros. They've moved it over twice from 17, so it's gone over once twice. If you have a number like 5 over 100, there's 2 zeros. The decimal place is here. You move it over twice, 1, 2. And now that it's made this empty gap, we have to fill it in with a 0, so that's why we get this 0.5. 3 zeros for the next two, we move it over 3 times, so 323, 1, 2, 3, we get 0.323. With 47, it's a smaller number, so we move it over and then we need to add this extra 0, so we get 0.047. Big thing that we'll be using, percentages. Percent basically means per 100 or out of 100. So when we think of a percent, 15% for example means we have 15 and we divide it by 100. So you get 0.15. So same rule here applies. We move the decimal place over 1 or 2 places. So from 15 it goes to 0.15. This is going to be big for when we talk about interest rates in a couple of days. But generally speaking, because percents are all out of 100, you're always going to be moving the decimal place over to the left twice. If you go from something like 0.15 and you want to express it or show it as a percent, you're going to do the opposite of dividing by 100 and multiply by 100. So that's going to do the opposite thing, and it's going to move the decimal place over to the right 2 times. So you're going to get 15, and then you add a percent sign to show that it's not 15, it's 15%. So as a rule of thumb, if you're multiplying by some power of 10, so if you're multiplying by like 10, 100, 1,000, etc., multiplying by any one of these moves the decimal place to the right, and dividing does the same thing, but the decimal place moves left. So keep that in mind, that's a good thing to remember. We're at about 8 minutes. I'm going to keep going into some of the questions. So for these, I'm going to move the dollar sign over, and we're going to go through this real quick. Basically, they have it nice lined up for us with the columns, but if you're dealing with money, always give yourself a cent column. So there's going to be a decimal place that we carry down. 6 plus 8 is 14. Carry the 1, and I get 8. Work through 1 plus 2 plus 1 plus 3. I like to make this easier for myself by grouping them. So I see a 3 and a 2 is a 5. 2 more 1s makes 7. And I'm trying to make either 5s or 10s. So 4, 3, 4, and 2. So I see 2 4s, which make an 8. A 2 makes a 10, so I have 10. There's a 3 left, and I bring the 1 up. Last but not least, 7 and 3 make 10. This makes 9, and this makes another 10, so I have a 0 here, and a 2 goes here. Not too bad. The one difficult is that we're dealing with dollar signs. We don't add the dollar signs, we just move it down to represent that it's still money. The other thing that we're going to encounter is things like this. So what this is actually reading, this is how we show imperial measurements. So for example, what this is actually saying is 1 foot. And 4 3/4 inches. So keynote, this sort of one line means feet. If you see the kind of quotations, it means inches. And the dash here is it's not subtracting, it's saying 4 3/4 inches. So what I would recommend doing here, you're going to add your inches first. You're still going to start from the right, but I'm going to start with these fractions. So I have on the side 3/4 plus 3/4 plus 3/4, which gives me, since they're all the same, I can keep the bottom the same, and I end up with 9/4. I don't like improper fractions, so I'm going to call this 2 1/4. This 2 is what I'm going to add up top here. So there's going to be another 2 inches from that. So I have 1/4 inch here. Now I have 2, 4, 6, and 2. I see that 4 and 6 make 10. Another 2, or 2 and 2, so I have 14. Now, difficulty here, I almost made the mistake. I wanted to bring the 1 up here, but keep in mind we're talking about measurements, so 14 inches is not 1.4 feet. What it actually is saying is 14 inches, and remember, there's 12 inches per 1 foot. So what you actually have to do is take out 12 from here. So if you take out 12, you're left with 2, and then you have 1 extra foot. Now adding all these together, I have 1, 2, 1, and 7. So I have 10 here and 11, so I have 11 feet. And then 2 1/4 inch. And if I want to express it the same way, I'm going to include these little quotes and the little symbol up here that represent feet. Alright, keep moving on. A lumber order that you were preparing is as follows. You have 24, we call them 2x6s. It's a board that is 2 inch by 6 inch. So all of these represent the measurements of the board. For example, if you were to look at the side of a board that is a 2x6, we don't know how long it is, but it would be 2 inches by 6 inches. For a 2x10 would be 2 inches tall and then 10 inches wide, so it would be sort of a wider board. And then 2x4s, they're going to be narrower than the rest, so it's 2 inch by 4 inch. The question is, what is the total number of planks that you'll need to show your work? So in each of those cases, it tells us what the plank looks like, but that's a little bit of misinformation, because we're saying we're ordering 24 2x6s, 30 2x10s, and 55 2x4s, and we're just concerned with the total number of boards in total. So what this question is actually asking is, or for us to do, is go 24 plus 30 plus 55 equals, doing this quickly, 85, 109 boards. So be aware, with word problems, they like to give you a little bit more information than you need. This one didn't need what the boards looked like at all. So just keep that in mind. Next up, we have 3 deliveries of 1x6 board roofs that are as follows. We have 2,450 BF, 2,760 BF, and 2,875 BF. And then it says, what is the total board feet of the wood delivered? Now, key bit, we're going to translate. We're going to assume that BF represents board feet, because it's not a symbol that we're used to, but suddenly it says it over here. And when I ask questions, I will try to be explicit by saying, in brackets, BF. So in this case, it's just asking the total amount. I can just add these up the same way. So I'll just set up this question for us. I won't actually solve it, but you can see after this point, it's pretty straightforward. We're just adding everything together and we're done. All right. Now we're dealing with subtraction. Supply of plywood in stock is 9,987 SQFT. This represents square feet. After a contractor purchases 6,976 square feet, how much plywood is left? So this is our sort of our total, and this is taken away. So what this question is asking us is to subtract these two numbers. I'm going to do this one. So you build a deck for $450, your material and labor costs $347. So how much do you get in profit? So total paid is $450. Costs is our $347. So again, we're subtracting that to see how much we get. Again, I'll just set this up. Multiplication, you know what, I'll skip this one. Linear feet. How many linear feet of cedar are there in 9 bundles, each containing 10 pieces that are 12 feet long? So we need to know total boards. So we have 9 bundles, each containing 10 pieces. So in total, we have 9 bundles times 10 pieces each. So this is going to be a multiplication, so 9 times 10 gives us 90. Each one is 12 feet long, and it wants to know how long it would be if we put them end to end. So when it says linear feet, imagine taking the boards and sticking them like this, just all in a row. So if each one is 12 feet, rather than going 12 plus 12 plus 12 90 times, an easier way to do it is now we can go 90 times 12. And we end up with 1,080 feet. Alright, so now we're looking at division problems without the use of a calculator, so it's good to have some idea of how we can break these down fast. The way I've always learned is through long division. So to set this up, 450 divided by 5. I am looking for the first set of numbers that work. So 44 does not go into 5, 45 does, that goes in 9 times. So then I get 45, which gives me 0. I bring down the new 0 when I subtract. And then 5 goes into 0, 0 times, there's no remainder. So my answer is 90. So then next up, 1,080 divided by 90. I have to go all the way to 108. I get 1, subtract 90 from it. So then I get 18. And then bring down the 0, I get 180. So I can fit it in 2 times. I get 180. Subtract gives me 0, no remainder again, 12. Last but not least, 1,540 divided by 5. I'm looking at 15 giving me 3. Then I bring down the 4, doesn't work, so then I'll bring down 0, and then I bring down the 40, which goes in 8 times, so then gives me a nice even 40. So 0, again, no remainder, 308, done. Next up, the word problems surrounding division are a little bit complicated, but how many joists, space 16-inch OC, are needed for a building that is 36 feet long? So there's 2 parts to this. Basically, if we think about it, there is a house or a building 36 feet, and every 16 inches I need to have some sort of stud or beam. So each one of these is 16 inches apart. Key bit, where we need to start before we just divide 16 by 36, is they're in different units of measurement. So we have 36 feet and we have 16 inches. So to convert this, I need to do 16 divided by 12, because there's 12 inches per feet. So I'm going to get 1, I'm going to get 12. So now subtracting, I get 4. And now I have to have a decimal point. So there's an invisible decimal point here. I keep going, bring down the 0. 40 goes into 12 3 times. I get 36. So then I have 4 left over. And then I can see if I bring down another 0 here, I'm going to get 40 again. I'm going to get 36. So 1 1/3 feet. So I'm going to keep getting 3s, so I'm just going to put 1.333. So now, this is saying how many feet. So I have 36 feet, and each joist is 1.33333. So I'm going to divide 36 by 1.33. And for this one, I'm going to use a calculator. This is where we start to get a little bit complicated. Notice how this one says that it's okay for us, or it doesn't say to not use a calculator. So punching that in, I get 36 divided by 1.333. I get 27. Now, that counts spaces in between. If I have to start with one joist, I have to add 1 as a starter, so then I'm going to add 1 to get 28. So my answer is 28 joists. Same idea with question 7, where they're talking about joists, and same thing with number 6 for studs. I realize we're running a little bit long, so I'm going to skip 6 and 7, but they function the same way. Key things, or keynotes: watch for units and try and unpack what the question is asking. So that's all I have for you today. Thanks again. I'm going to be posting stuff on Friday regarding our first actual lesson. It's going to be going into financial institutes. There's going to be some vocab around it, but for now, this is how we're going to get caught up and just kind of have an idea of where we're at. Give some of the other questions a try. If you're ever stuck, feel free to ask, and I can go through one of them with either an example, or we can meet face-to-face, or I can send an image remote. Or if enough people ask, I can also make a little video on it. So thanks for tuning in. Stay safe. Have a good one. Bye.